All right, we're going to get started. Now, with these two, my internet stalking skills failed me entirely. So we have Barbara Chassoul and John Chassoul. And all I really found was that she's a former physicist, and he likes to tweet art. And they're from Costa Rica. And they're going to talk to us about StarCraft.
Yeah.
Yes. Thank you. StarCraft AI and the BIM ecosystem. The purpose of this talk is to present the current state of affairs of our applied research with PyTorch, Lua, and Airline. Well, we're members of an open source research and development community based in Costa Rica that conducts multidisciplinary work on distributed systems and artificial intelligence and high-performance computing. Our mission is to provide tools inside and a simple workspace to play and work in science. Our goal is a distributed AI toolkit and workspace environment for machines of all ages. So why do we choose StarCraft? Well, StarCraft was originally released in 1998 and is still one of the most popular online games in the world. After the release, StarCraft gained popularity in South Korea, establishing a successful programming scene. StarCraft also represents a well-defined adversarial environment which pose a number of interesting challenges in areas of information gathering, planning, dealing with uncertainty, and domain knowledge exploitation, task decomposition, and spatial reasoning. Simplicity plays a very important role in our principles. It means that the basics of our system should be very simple and allow us to build complexity on top of it. Functions are a form of objects. Message passing and function calling are analogous. Asynchronous message passing is necessary for non-blocking systems, and selective receive allow to ignore message uninteresting now. The first two are forgotten from Lisp, and the others, well, they sound familiar, right?
So to explain our current state of affairs, we should provide background on the ideas behind our research. Jean Piaget's definitions of intelligence itself does not consist of an isolated different cognitive process. It's not one form of structure among others. It is the form of equilibrium towards which all the structures or cognitive processes tend. Intelligence is only a generic term to indicate the equilibrium of cognitive processes. Jean Piaget believed human beings inherit a tendency to organize their intellectual processes and to develop particular adaptations to their environment. Organization refers to the tendency for all species to systematize their processes into coherent systems, which may be either physical or psychological. Adaptation is the balance in between the independent processes of assimilation and accommodation. Intellectual adaptation is also an exchange between a person and its environment, and involves the same two processes of assimilation and accommodation found in biology. Assimilation involves the person dealing with the environment in terms of its structures, while accommodation involves the transformation of its structures in response to the environment. The particular ways in which an organism adapts and organizes its processes depend also on its environment and its learning history. Organizational behavior is the study of human behavior in an organizational settings, the interface between human behavior and the organization itself. It has been influenced by developments in sociology, organizational psychology, and economics. What is an organization such as a business? It is a building, a collection of machinery, a legal document containing the statement of incorporation. It is hardly likely to be any of these things by itself. Rather, to describe an organization requires the consideration of a number of properties it possesses, gradually making clear, or at least clearer, what it is. Whether it is formal or informal, work is accomplished by a collection of members whose effort and behavior become coordinated in order to attain sub-goals and objectives. An organization inherits the integrate behavior of its organizational members. Some of them are like, we can describe it as perception and behavior, simple as the statement, he acts as if he thought. It illustrates two important points. First, what the person thinks he sees may not actually exist. The second, people act on the basis of what they see. Clues. The interpretative meaning we attach to concepts we learn, like when we are able to communicate with a person without speaking the same language. Threshold of perception. It is the stimuli to which we are sensitized, and when these appear, we are instantly alert and eager to examine them or block them out. Resonance. The ability to sense or feel what others might be felt just by thinking on being on their situation. Internal consistency. We seem to tune out the elements that do not fit. For instance, we might look at some draw and see a rabbit. The draw might also suggest a duck, but we do not have an image of something half rabbit and half duck. In fact, if our first impression is a duck, we might never notice the portion that looks like a rabbit. Dealing with conflict. How can we eliminate it? But it is conflict of such a type and within circumstances where it will contribute rather than decrement from the organizational interest. Confidence, loyalty, and comparative motivation produce earnest, sincere, and determined efforts to find solutions to conflict. Programming links are the given instructions to report immediately on task completion. Progression of goals. Organizations have progressions of goals which result from a division of work. This nesting of goals is contained as part of the core organizational mean-ends change, goals and feedback. It is important to show how a situation in one area could lead to modifications in a number of organizational units at higher levels.
In 1986, James McLean, David Rutherford, and the PDP research group present a model called the Blackbird Model. It had not fixed a processing structure, but one that is dynamically configured for in the course of processing using contingencies between hypotheses to construct solutions on the fly. This model is based on the idea of connection information distribution. The idea use information stored in one part of a processing system to set or program connections to another part of the same system. The idea of using a common Blackboard where multiple agents can read and write is very old in artificial intelligence. Going back to the pandemonium system created by Oliver Ziegfeld in 1959 to coordinate the action of several demons. The Blackboard architecture is based on the following model of problem solving. It's a group of experts watching a solution being developed. Whenever an expert feels they want to contribute towards a solution, he goes to the Blackboard and makes the appropriate changes or additions. The key ideas of the Blackboard are that behind this model is there's a problem solving. The problem solving should involve it should be incremental and opportunistic. The model emphasized the adaptation between strategies as data loads, ambiguity, system goals, and available time. Solutions should be constructed piece by piece at the different levels of abstraction, working with available data at the intermediate state of possible solutions, suggesting the most progress can be made. So why do we use the Blackboard approach? Well, process can be developed in the most appropriate language for data and objects as they are to handle. One process might be naturally written as a rule-based system like Luerl because of its speeds, and while another might be written as a nodal network with Python using TensorFlow or PyTorch. Our concurrent process, well, like the beam. The most general way of extending the benefits, connection, information, distribution is to note that it is analogous in a way of the invention of a stored program. Shared memory is evil. By copying data around in messages enables full tolerance, concurrency, and parallelism. That's a very high performance feature, but even the HPC field is built around copy and sending data. The MPI must be the ugliest of the message passing abstractions, but it is a message passing system after all. One of the interesting conclusions of McLaren describing the programmable Blackboard model was that he didn't do anything more than show how existing tools in an arsenal of parallel distributed processing can be used to create local copies of networks.
We build around the ideas behind the Blackboard, described by the connectionist using a modified version of the ship demo developed by Robert Bearden, presenting a message passing system extracting events from StarCraft and send them to the simulator to interact between the rest of our components. Erlang is the right tool for our Blackboard and is used as a system for coordination, distribution, and control. React is used as a distributed key value storage for the rest of our backends and components. Lua is the big protagonist in our system. We exploit the speed of Luerl in our bot game heuristics and the scripting capability that Luerl brings to the Beam ecosystem. PyTorch and SciPy are used for data analysis and the implementation of artificial neural network models. We use Salt for automatization tasks within our infrastructure and Tornado for our Python backends. Since the first StarCraft AI competition in 2010, the field of real-time strategy game AI has continued to rise in popularity every year. In 2010, the first StarCraft AI competition was held at the University of California as part of the Artificial Intelligence and Interactive Digital Entertainment Conference. In the same year after the success of the AIDE, there was an attempt to hold a competition as part of the AEEE Computational Intelligence and Games Conference. Later the next year, the first student StarCraft AI tournament was held at the Comenius University at Bratislava. Last year, the Basil ladder was announced with automated support for most student StarCraft AI tournament bots based on Docker images, opening the door for non-Windows competitive bots. Until this time, this wasn't a space which only C++ bots and Java bots was able to compete. Currently, the annual EEE COG StarCraft AI competition is organized by the Cognition and Intelligence Lab at the Department of Computer Engineering in Sihon University of Seoul, Korea. It is sponsored by the AEEE Conference on Games. Currently, there are more like 80 bots from different authors around the world, from individuals to universities to private research groups from industry like Facebook and Samsung. We're still at what we call a larva stage, working on the integration of the Blackboard with the rest of our components, even though competing seemed a little bit far right now. That is, of course, the main goal of this project. And let me show you a last little demo, and that will be it. Sorry, guys. Next term. Oh, fuck. Where is the mouse?
One second.
Well, apparently the demo gods are not with us today. Yeah. I don't know why I can show you like in the big screen, but it's playing, it's running. So, yeah. Technical issues, I'm sorry. But it's playing. Yeah. Without hands. So, thank you, guys. So, any question? If we have time. Yeah. It's even creating the spanning pool now. So, startings are coming. Yeah.
Hello?
Hi.
I have heard of like a DeepMind playing StarCraft 2, so I was curious, what is the difference between playing StarCraft 1 and StarCraft 2?
Well, to be honest with you, and it's probably my strong opinion, but Blackboard is the better game, right? It's more difficult. It have a strong community, not only on the pro gaming scene around Korea or in the world in general, but it's believed to be a more difficult game than StarCraft 2. It's completely different, just the name are shared. And yeah, what DeepMind is doing is really interesting and really great, but we think as part of the AI StarCraft niche, I guess, yeah, there is even more work and challenges. The scene is bigger on the Broodwell side of things. Yeah, but we can compete with the Google PR, right? So.
So you said you use both Luerl and Luerl.
Yes.
How do those interact?
Okay, Luerl is for the heuristics for the bot, and Luerl is where the simulator that Robert builds is built on Luerl. So our Blackboard is implemented on Luerl, and the static logic of the game heuristics is used with Luerl processes, and how they interact is with using 0MQ as a message passing layer. Actually, all of this is possible thanks to an open source project from the Facebook group called StarCraft, which is like the glue in between the engine of StarCraft and whatever other language you might choose to build bots, thanks to the 0MQ integration that they built for us. Hi.
Quick question. I was wondering, how did you train the model for your inference?
Okay, so one of the great things about the Blackboard is that the model gives us the possibility to use the right tool for the job, kind of, so to speak. So what we extract from the game of StarCraft is all the events that they are doing in real time. We store it on the Blackboard, and for them, we then feed our models that are mainly built with Python using the PyTorch framework. All right, you're welcome. So, any more questions?
Did you actually win the tournament, or?
No, we have been able to compete yet. The current state of the competition of our bot is not ready yet to compete. What we have been doing is working on the research work that we present today in order to. We, of course, plan to participate in competitions, but it has been hard because they have this little requirement that everything must be run on Windows, and our architecture is kind of like Unix-based. Yeah, it's quite sad. But the basic ladder, which was announced last year, is the one. Is like the first event that they include the possibility to run systems on Docker containers. We actually don't like Docker. We are most of the Singularity kind of guys. Singularity is this container solution compatible with Docker that is getting out from the HPC space. Is built from the same guy that brought us technologies like CentOS Linux or the Beowulf cluster. Is compatible with Docker, is great. It has full support for the GPU, and that's why we choose to use it. But yeah, it has been hard. The Windows thing is not helping, but we're getting there.
Any other question?
All right, well, our time's up anyway.
All right, so thank you.
Thank you.